Is the United States going to manufacture clean energy technology products? This is potentially a gigantic global marketplace over time, growing into the trillion-dollar sector. Our ability to enter that sector, sustain that sector, is going to be significantly dependent upon our ability to manufacture and produce in that area. So manufacturing is a core question for the next, whether the U.S. is going to participate in the next generation of clean energy technology products. David has been doing remarkable work at DOE on this task. The second issue is increasing energy productivity in U.S. production systems. There are huge opportunities for gains in manufacturing on this side in general. So are we going to support the efficiency and the enabling technologies in that efficiency side of U.S. production? So two base questions here, and a significant part of the answer on both really lies on manufacturing. So I'm going to give you kind of a backdrop. I know you talked about manufacturing 2 years ago. We have learned a lot since. There have been a whole series of major reports out. The most recent important one came from the Advanced Manufacturing Partnership, a combined industry-university collaboration reporting to the President, made a whole series of recommendations that are now in the process of implementation. David will talk to you about some of those, and Mike Molnar a little later. But what's this manufacturing context for the energy technologies? That's really what I'm going to try and focus on. And there's a series of points I want to make. And I'll just list them, and then we'll walk through them a little bit. Manufacturing is not agriculture. And I'll explain that. Our manufacturing firms are increasingly what we could call home alone. This ecosystem has really thinned out over the last 10 or 15 years. There's a real issue for small, mid-sized firms and startup entrepreneurial firms that make things in getting financing to actually scale up the innovations they're coming up with. Strong innovation capability, historically a U.S. strength, requires strong production capability with it for reasons we'll discuss. Manufacturing is really needs to be seen as part of that innovation system. There are big workforce training and education issues that may be particularly relevant to you all. There's lessons from Germany. And there are some important understandings that I think we're coming to about jobs and employment, how they relate to manufacturing. So first, manufacturing isn't agriculture. For a long time, economists told us they were the same. So in 1900, half the population of the United States was engaged in farming. Now less than 2% of the population of the United States is engaged in farming. We're producing more than ever. So there have been enormous productivity gains in farming, and between 2000 and 2010, we lost 6 million manufacturing jobs, about 30%, a little more than 30% of that whole workforce. The economists thought, oh, it's a story of productivity gains. It's the story of agriculture. But it turns out that the new reports and the new data tells us that output wasn't what we thought it was. And if output isn't what we thought it was, then productivity is not what we thought it was. And that the whole sector was actually in decline. It was beginning to hollow out. It wasn't really a story solely of productivity gains, although there were certainly productivity gains in that sector. Point two, home alone. So the reports tell us that for the last several decades, we've been thinning out our manufacturing ecosystem. We used to have firms and supply chains that were very vertically integrated. We hit on a financial model that emphasized short-term returns, which led us to reduce risk by making our firms, focusing our firms on more core competency, less vertical integration, making them much more asset light, spinning off assets. That thinned out a lot of the manufacturing ecosystems, particularly for sort of shared assets that were between those firms, areas like training and best practices for suppliers. So increasingly our firms, particularly our Main Street firms, our small and mid-sized firms, are much more home alone than they've been in the past. We have a scale-up problem for production. So we have many industrial sectors, but we can kind of look at manufacturing overall as kind of having three components. We have big multinationals, they're global. The US still retains the largest number of major multinationals. They can get their production efficiencies by producing abroad in lower cost countries, and they have to be in these global markets. So, you know, generally speaking, they're okay. But there's two more vulnerable sectors in manufacturing. The Main Street firms I referenced earlier, there's about 300,000 of these. These are the small, mid-sized firms. They do the majority of manufacturing. They're having real trouble getting this production scale-up funding. So when they're ready to innovate, they have real problems with rapid scale-up. They're thinly capitalized. They have to be risk-averse to survive. They don't do R&D as we think about it, although they can be very innovative in process if they survive. But they're having trouble scaling up their innovations. Part of that is the end of local banking, right? We've shifted to national and indeed international banking models, not local customer-based models, and that's part of the story for them. And then our entrepreneurial startups that actually make something, that they produce something unlike software that if it fell on your foot, you'd feel it. They have trouble getting financing at that scale-up moment. They may well be able to get venture and angel financing, but when it comes money, you know, typically what occurs, the phone call occurs. They call their venture firm for like a new energy technology. Hi, venture firm, please send me a check for $30 million so I can scale up production. No, we don't do that. Call our contract manufacturer, you name the country, right? We are increasingly sending that production stage abroad to contract manufacturers abroad, which has important implications. Because, point 4, there's a deep tie between innovation and production. So most products, you need to tie innovation pretty closely to the initial production stage. And you all know this. I mean, there's deep feedback loops as you do the product design and the initial production planning that requires very creative engineering, very creative science. You often have to rethink the original science and the original engineering behind the technology. It's all part of a very creative innovation stage. So as you shift production capability abroad, you're going to be shifting innovation capability with it. So again, production needs to be seen as part of the innovation system. We typically think of innovation as R&D, but we all know in this room, I think, that it's a more complicated story than that, and that particularly that initial production stage is just key to the whole process because so much of the innovation occurs as you move towards production. Production is the major enabler of what we can call increasing returns in the economy. That's the way growth scales fast. It doesn't scale through the services sector, which is much slower to scale. It scales through manufacturing. So that's a pretty important part of our overall capability. Point 6, workforce. MIT did a study a couple of years ago with 3,000 manufacturing firms. All of us have been hearing about a real skilled labor shortage in the manufacturing sector. It turns out that 75% of jobs from those companies could be filled in less than a month. So there's not an emergency here. But it's the other 25% that's actually pretty interesting because the smaller, more innovative firms tended to be in that 25% that couldn't fill those jobs quickly. They required higher level job skills. That's kind of a signal to us that if we want to move to advanced manufacturing, we're going to have to really focus on getting that new skill base into the job base. And there's a huge issue for engineering education. You know, we're not going to do nanofabrication unless trained engineers are ready to snap those technologies into the production system. It just will not happen. So how do we need to think about advanced manufacturing and the generations of engineers that you have already trained and are training? Point 7, can we learn some lessons from Germany? So the United States basically thinks that we have to lose manufacturing because, you know, there are low-cost producers in Asia and we're very high wage. We've just assumed that that has to happen, like some unwritten rule. But Germany is high wage and high cost. In fact, it's much higher wage than the United States. It's 66% higher wage in manufacturing jobs than the US. 20% of their workforce is in manufacturing as opposed to 11% in the US. They're running a major manufacturing surplus, including a surplus with China. What are they doing, right? Are there lessons that we could pick up here? So one thing that they're doing is that they built a very deep ecosystem, while ours is thinning out, for their manufacturers, small and large. They aren't home alone. There's a very extensive collaborative R&D system shared by industry and government universities, the Fraunhofer system that I know many of you are familiar with, around new manufacturing technologies and processes. It works pretty well. They have a remarkable training system. They are very good at linking their supply chains for rapid production scale-up. Some interesting lessons here. Some are not applicable. Their apprenticeship system probably doesn't fit the way we're going to do workforce training, but there are some real lessons here. Point 8, the last one, jobs. The manufacturing sector affects the service sector. So we're 80% services in the US, but it looks like the 21st century firm is going to tie complex value-added goods to services to provide solutions. Now that's very interesting because services, as I said earlier, doesn't scale very fast, right? Production can scale very fast, right? So if you tie a tradable good to a service, then the service becomes tradable as well. In other words, it can scale at a much faster pace than services normally scale. And if we're 80% services, we should pay attention to this lesson because it's going to have a lot to do with the success of our services sector. Let me just dig a little deeper behind that and talk about why. So arguably, there may be an hourglass with the production moment, right? That assembly moment in the middle of the hourglass. And there's about 12 million jobs there. But flowing into that hourglass are all the resources, suppliers, components, and a large part of the innovation system, since over 60% of scientists and engineers are employed by industrial firms. So those are all inputs going into that production moment. And then the outputs, the whole distribution, the whole sales, the life cycle of the product, that's a huge sector too, much bigger than manufacturing per se. And there are value chains of firms that flow throughout this hourglass. So when you extract the production moment, you wreck all the value chains that flow through it. Now, the bottom part of the value chain, if you substitute an imported good, can be replaced because you're still going to have a distribution sales life cycle. The participants will have to change. But you can restore that over a significant period of time, but you never restore the top part. So it may be that part of the reason why the recovery from this last recession has been so slow is because we really kicked the manufacturing sector and our production capability in the process of it. So manufacturing is part of an innovation system. Manufacturing is not agriculture. Manufacturing firms in the US are in a thinned out ecosystem. They're increasingly home alone. We've got a real scale-up problem in providing financing for production to both small and mid-sized firms as well as startups. There's a very important linkage between our innovation capability and production, particularly initial production. There may be some new production paradigms. We've got some interesting things to do on workforce and education. Germany may provide some interesting models, and we've got an interesting tie to our kind of enduring quality jobs problem in the US. There are policy links to these points. David is going to talk about some in the energy sector, which he has been leading. Mike Molnar will talk about more. But it looks like there are transformative technologies. And it may be that we can develop technology strategies for them and link them to the R&D system, and then in turn link that to this new generation of manufacturing institutes and network those institutes. So this is a promising space for your schools, right, and for your talent groups. You know, we're going to spend, I'll say this only in this room, but we're going to spend $500 million on manufacturing institutes this coming year. We're going to move to 15 of these. There are whole new spaces for demand-driven workforce solutions. There are technology scale-up policy steps that we need to take. These are some of the issues that we're going to need to reflect on. But I think that there's a whole new role for engineering schools, and many of your schools are already starting on this, to play in what could be a very creative set of opportunities for the overall U.S. economy and a particularly creative set of opportunities for engineers. Thank you.